In 4.3 notes, we're going to talk about dividing polynomials. So we divide polynomials super similar to how we would divide with big numbers. So let's say we had something like 532 divided by 2. Well, we'd first start by saying 2 goes into 5 2 times. We'd multiply 2 times 2, which would be 4. So we subtract 5 minus 4 would be 1. We bring down the 3. 2 goes into 13 6 times. We multiply 6 times 2, we get 12. And subtract, we get 1. Bring down the 2. And 2 goes into 12 6 times. So when we divide, we'd get 266. So it's kind of the same process, but we're doing it with a polynomial, so doing it with coefficients and variables. So when we divide, I'm going to use the same example with numbers like we did on the last page. If I had 2 divided by 532, like I had on the last slide, 2 would be our divisor. That's the number that's going into it. The answer, so I had 266 as the answer. This would be our quotient. And then we didn't have a remainder in our answer, but if we had a remainder, that would be our R, or remainder, whatever the number would be. Here, our remainder was 0. We had none. But we would write it as our quotient plus the remainder. So this number was our remainder over the divisor. So I'll show you how we write it once we get into some examples. But this would be how you would type your answer into the homework. So example 1. Our divisor is x minus 1. So that's going to go on the outside, x minus 1. Inside the box, what we're dividing into would be x cubed minus x squared minus 2x plus 8. Now, when dividing with polynomials, there's 3 steps that we follow, and we just repeat these 3 steps each time. The first step is to divide. We divide x to the third power divided by x. So our first term divided by our first term. If I had x to the third power divided by x, I have 3 x's and I'm taking 1 away, so I'm left with x squared. Now x squared, I'm going to write on top of the x squared term because I want to keep my like terms in line. It's super important for these questions that we are organized. So you make sure that you are organized for each step because you follow the same pattern and you don't want to get lost. Step 2 is we multiply. So I take what I just found, that x squared, and I'm going to multiply it by both terms out front. So x squared times x would be x to the third power. We're always going to get the same thing over again. So I had x to the third power. I'm going to get another x to the third power. It's always going to repeat there. And then x squared times negative 1 would be negative x squared. After we multiply, step 3 is to change the signs and combine. So we're going to change the signs of these 2 terms and combine them together. So it becomes a negative x to the third power and a positive x squared. Now x to the third power minus x to the third power cancels. They're the same thing. They cancel out. Your first terms will always cancel. Just so happens here that I have a negative x squared plus x squared, so these cancel out too. So now I have to move on to my negative 2x. I'm going to drop that down because I'm going to repeat the same steps again. So step 1 is divide. I'm going to divide negative 2x divided by x. So if you need to see it, let's write it out on the side here. Negative 2x divided by x. Well, the x's cancel and we're left with negative 2. So -2, I'm going to write, since that is a constant, I'm going to write it on top of the constant number. Once we divide, we can move on to step 2, which is multiply. So the last number that I wrote was that -2. I'm going to multiply that times both numbers out front. So -2 times x will be -2x. Again, you're always going to get the same thing. And then -2 times -1 would be +2. Step 3, change the signs and combine. So this turns into a +2x and a -2. So we combine our like terms here. They cancel. And then 8 minus 2 would be 6. Now I have 6 divided by x. I can't take away any more x's from 6. So 6 is going to be our remainder. So sometimes you might see it as remainder 6 with R6. The Big Ideas wants us to write it a little bit different. So again, you might see it written this way on either like an SAT. It could be written both ways. So you have x squared minus 2, what we just wrote on top. That is part of our answer. That is our quotient. And then our remainder, we say plus 6 over our divisor, which was x minus 1. So you just write the remainder on top of what you were dividing into the question, that x minus 1 there. And this would be our answer. So this is how the Big Ideas wants it. So with long division, it's the same 3 steps each time. We divide, multiply, change the signs, and combine. And you just keep doing it again and again until you run out of terms. We ran out of terms here. Notice how these are all of our constants. All of our x's were in line here. All of our x squared, or x cubes in line. So it's the same pattern. We're going to do it again with a new example. So let's look at example 2 on the next page. Outside the box, I'm going to write my divisor. So that'll be x minus 2. Inside, I write what I'm dividing into. So x cubed minus 3x squared minus 7x plus 6. So we start, step 1 was to divide. X cubed divided by x. If you need to write it down to see it, write it down. So if I have 3 x's and I take one away, I'm left with 2 x's, so x squared. Step 2 is to multiply. So we multiply x squared times both things out front. So x squared times x is x to the third power. X squared times -2 would be -2x squared. Step 3, change the signs and combine. So we change the sign, and combine. So x cubed minus x cubed cancels. The first terms are always going to cancel if you did the step right. Next, we have -3x squared plus 2x squared. So we're just combining our coefficients together, which would be -1x squared, or just -x squared. Once we change the signs and combine, we do the 3 steps again. So start by dividing. We have x squared divided by x. -x squared divided by x. So if I have a -x squared and I take an x away, I'm left with -x. So I'm going to write that on top in line with my x term. So -x. After I divide, I multiply. So I'm going to multiply -x times both things out front. So we get -x times x would be -x squared. -x times -2 would be plus 2x. Step 3, change the signs and combine. So we make it a plus x squared and a minus 2x. Combine them together. The x squareds cancel. Next, we have -7x minus 2x would be a -9x. We do the same thing again. Divide. We have -9x divided by x. -9x divided by x. I'm taking away one of the x's, so I'm just left with negative 9. So negative 9 is going to get written on top of my constant term. Negative 9 times x would be negative 9x, and negative 9 times negative 2 would be positive 18. Step 3, change the signs and combine. Change the sign, combine. Negative 9x plus 9x cancels. I'm going to drop down the next term to combine these together. 6 minus 18 would be negative 12. Now I can't take away any more x's from negative 12. It ran out of x's. We don't have any more. So this would be our remainder. So our answer is x squared minus x minus 9, remainder negative 12. Now we can't leave our answer like this for the homework. We have to write it in fraction form for our remainder. So we have x squared minus x minus 9. Because it's a negative 12, we have to write minus 12 over our divisor, which was x minus 2. So this would be our answer for big ideas. All right, so let's do it again. So same thing here. We're going to write our divisor on the outside, so x squared minus x plus 1. And then what we're dividing into is going to go on the inside. However, one little thing that we have to check for each time we divide is that we have all terms represented here. So we need all terms. And what I mean by that is that if we start with x to the 4th power, we need x to the 4th power, x to the 3rd power, x squared, x, and a constant. So here, I'm missing x to the 3rd power. So I need to put a 0 x to the 3rd power in that spot. So this is going to act as a placeholder to keep all of our like terms in line, but we need to have that 0x cubed in that spot. And it has to be 0 as our coefficient because it's not just an x cubed. If we said just x cubed, it'd be like saying 1x cubed. And then that's going to change the value of the problem. But putting a 0 in there is not going to change any of the values. It's just like adding 0. It's just going to act as a placeholder. So inside my box, I'm going to put x to the 4th power plus 0 x to the 3rd power plus 2x squared minus x plus 5. Now step 1 is to divide. We divide the first term by the first term. So if I have x to the 4th power divided by x squared, here I'm taking 2 of the x's away. So if I have 4 x's and I take 2 away, I'm left with x squared. So I'm going to write that on top of my x squared term. Once I divide, step 2 is multiply. So we multiply x squared times everything out front. So here we have 3 terms out front. But it's the same steps. We have another term that we have to make sure we multiply by. So x squared times x squared would be x to the 4th power. X squared times negative x would be negative x to the 3rd power. And x squared times 1 would be x squared. Step 3 is to change the signs and combine. Change the signs. So this becomes a negative x to the 4th power, positive x to the 3rd power, and negative x squared. When we combine them together, the first terms are always going to cancel if you did it right. So x to the 4th power is cancel. 0 x cubed plus 1 x cubed would just be 1 x cubed. So if you want to, you can put the 1 there just so you know that it's a 1 to help you. But remember, we don't write that in our answer. If you need to see it, the 1 there, you can. And then 2x squared minus x squared. Again, this would be 1x squared, but we don't write the 1 there. If you need to see it in your work, you can keep it there, but we don't write it in our answer. All right, once we change the signs and combine, we do it all again. Step 1 is to divide. X to the third power divided by x squared. If you need to write it down, write it down. X to the third power divided by x to the second power. If I have 3 x's and I take 2 away, I'm left with 1x. So I'm going to write that 1x on top. Step 2 is we multiply. Multiply x times everything out front. So we get x times x squared would be x to the third power. X times negative x would be negative x squared. And x times 1 would be x, positive x. Step 3 is to change the signs and combine. So this becomes a negative x to the third power, positive x squared, and negative x. Change the signs and combine. So we're combining it with all the like terms above. So x cubes cancel. X squared plus x squared would be 2x squared. Then we have negative x minus x would be negative 2x. Now we do it all again. Divide 2x squared. I'll write it on the side here so you can see it. 2x squared divided by x squared. Well, if I have two x's and I take 2 away, I'm just left with the number 2. So this would be plus 2. Next, we multiply. Multiply 2 times everything out front. So we get 2x squared. 2 times negative x would be negative 2x. And 2 times 1 would be positive 2. Step 3 is change the signs and combine. So this becomes a negative 2x squared, positive 2x, and negative 2. 2x squareds cancel. Negative 2x plus 2x would just be 0, so that cancels out too. And then I need to combine the 5 minus 2, which would be 3. Now I can't take away any more x's from 3, so that would be our remainder. So our answer would be x squared plus x plus 2, so my quotient that I wrote on top, then plus, because it's a positive 3 as my remainder, 3 over my divisor, which would be x squared minus x plus 1. So this would be our final answer. Again, notice how our like terms are in line. I have my x to the fourth power, x to the third power, x squared, x's, and the constant. Super important to be organized and keep your like terms in line. That way you know what's going to come next. All right, the next one is number 4. This is going to be the last example we do for today. And we will do number 5 in class tomorrow together, just so we can practice more. We're going to write our divisor out front. So that would be the smaller one, x squared plus 3x plus 2. Inside the box, we have to make sure all of our terms are represented. So I have x to the fourth power, x to the third power. I'm missing an x squared. So in here, I'm going to insert a 0 x squared. Then I have x to the first power and our constant. So we're good. We just need to make sure we put a 0 in the x squared spot to act as a placeholder. So 2x to the fourth power plus 3x to the third power plus 0x squared plus 5x minus 1. Step 1 is to divide. We divide 2x to the fourth power divided by x squared. So I'm taking 2 of the x's away, and I'm left with 2x squared. So that's going to go on top of my x squared term. Next step is we multiply 2x squared times everything out front. So 2x squared times x squared would be 2x to the 4th power. 2x squared times 3x would be 6x to the 3rd power. And 2x squared times 2 would be 4x squared. Step 3 is to change the signs and combine. So this becomes a negative 2x to the 4th power, negative 6x cubed, and negative 4x squared. Combine them together. Our first terms cancel. 3x to the 3rd power minus 6x to the 3rd power would be negative 3x cubed. And 0, x squared minus 4x squared, 0 minus 4 would be negative 4x squared. Now we do the same steps back from the top, starting with dividing. 3x to the 3rd power divided by x squared. So I'm just taking away 2 of the x's, and I'm left with negative 3x. After we divide, we multiply. Negative 3x times everything out front. Negative 3x times x squared would be negative 3x to the 3rd power. Negative 3x times 3x would be negative 9x squared. And negative 3x times 2 would be negative 6x. Next step is change the signs and combine. 3x to the 3rd powers cancel. Negative 4x squared plus 9x squared would be 5x squared. And then 5x plus 6x would be 11x. So we're combining these two together. Do the same thing again. Divide. 5x squared divided by x squared. We're taking 2 of the x's away. So then I'm left with 5, just 5. If I have 5x squared and I take 2 x's, I'm just left with the number out front. So 5 times everything out front would be 5x squared plus 15x, and 5 times 2 would be 10, so plus 10. Change the signs and combine. Do not forget to change the signs before you combine them together. 5x squareds cancel. 11x minus 15x would be negative 4x. And negative 1 minus 10 would be negative 11. Next step would technically be divide, but since I have negative 4x, I can't take away an x squared. I only have one x. I can't take 2 out. And I ran out of space. Once you run out of numbers, the last thing you write is your constant. The next thing is going to be our remainder. So our remainder here, let's write the quotient part. So that would be 2x squared minus 3x plus 5, the part up top. Our quotient here, since it's 2 numbers, we have to consider how we write it. So you can write plus. Up top, we have negative 4x minus 11 over our divisor, which is x squared plus 3x plus 2. Now we can actually simplify the top part a little bit more, because if you see, both of these are negative. So big ideas might accept this as an answer. It might not, because it can be simplified a little bit more. If we pulled out a negative from the top, we would say 2x squared minus 3x plus 5 minus, now we have 4x plus 11, because I'm taking out the negative from both of the terms, over x squared plus 3x plus 2. So I think that you could probably write it either way. I would be totally fine with accepting it the first way on the next test that we have, which is next Tuesday. But just be careful. I'm not sure how Big Ideas wants it. It might want it more simplified, which would be the second one. So either way is fine with me, but just be aware that these two are the same because we took out the negative in the second one. All right, last example, number 5, we're going to do in class tomorrow, but your homework is part 1 and part 2, so we're going to finish all the rest of the notes tomorrow. But for these 4 questions, homework is number 1 through 6, I believe. It's the ones that say long division. We're going to learn a different strategy on how to divide tomorrow. But you guys can start the homework by doing 1 through 6. So the long division questions.